Okay, so in this video we're going to go over what is a linear equation. And a linear equation is essentially just when you have an x and your highest variable is raised to a power of 1. There's a 1 in the index. So we could have x to the first plus 3x. As long as this x is to the first, it's still linear. We could add on a 30, could add on a 40. Although it wouldn't be simplified, this would still be a linear equation. And if we wanted to simplify it, you know what to do now. We're going to just take this term and add it to the one that's assumed to be here. That'll give us 4x. And I'm just going to add anything to the first power we know is just that number. So then we're going to add this 30 and 40 and get 70. So this would be our linear equation. Set that equal to 0. We're going to make those equal to 0. So what we're going to be doing here is I've listed 5 equations down here, and we're going to circle the ones that are linear, and the ones that aren't, we're just going to reason why. So the first one, well, we do have an x to the first here, but it's not the highest term. This is x squared, so this is not a linear equation. Let's look at the next one. Well, we got an x to the first, and it is the highest power. We could rewrite this as 9 minus x if we brought the 2 to the other side. That'd be our equation, and yeah, this x would still be the highest. So this one is good. Let's look at the next one. Well, this index is 3. 3 is bigger than 1, so this one is not linear. Let's look at 10 plus x. So if we brought that 1 to the other side, we'd have 10x plus 3 minus 1 equals 0. This would be 10x plus 2 is equal to 0. That x is to the first. It's the highest power, so yes, this is linear. Okay, this one over here. Well, first what we're going to do is we're going to distribute this x here. This will be x squared plus x is equal to 3. We're going to take that 3 to the other side. X squared plus x minus 3 is equal to 0. And that is squared, bigger than 1, so this is not linear. So that is what differentiates a linear from a nonlinear, is that index of 1 on the front term. If we had something like this, so let's say we had 3 equals 4. This gave us 0 equals 4 minus 3. 0 equals 1. Well, first off, this one can't exist because we started off with a bad argument to begin with. 4 can't equal 3. Okay, so let's solve the equation for x. So now we're going to talk about algebraically solving these guys. So the first thing we're going to do is take this 9 to the other side. We're going to add 9 to both sides. When we do that, we're left with 4x. This is going to be 1 plus 9, which is 10. Then what we're going to do is we need to get it by x. We're not solving for x squared. We're not solving for 4x. We're not solving for x plus 3. We're solving only for x. So what we're going to do here is divide both sides by 4. That'll give us x is equal to 10 over 4. But wait. These are both even because the last digit can be divided by 2. So what we have is x is equal to, take 2 out of the 10, we get a 5. Divide the bottom by 2, we get a 2. 5 halves, that can't be reduced. This is our answer. Okay, so now let's look at this next one. So first thing I noticed right off the bat is they both have a 30 in common. So what we can do here, make this real nice, is divide each side by 30. When we do that, those 30s will go away. That'll give us 5, 6. So now that they're not being multiplied by this 30 here, I'm just not going to write the parentheses. So we're going to have 5 6x plus 2 equal to negative 1/15 x plus 1. Okay, so when I look at this, we're going to have to get our x's together. And they have to be to the same power. So what I can do is I can multiply this by 1. I gotta think. I can multiply this by 2 over 2, and that'll give me a denominator of 30. If I multiply this side by 5 over 5, I'll get a denominator of 30. So that's just me looking at this equation and seeing what I have to do. So we're gonna have 5, 6. And then we're going to multiply that by 5 over 5. That'll give me x. And since I'm just multiplying it by 1, it's not going to change the argument. So I don't have to do it to one side like I have to do it to the other. Because this is just multiplying by 1, and we know that anything multiplied by 1 is equal to that thing. So if it was 2 multiplied by 1, it would just be equal to 2. So we're going to keep this 2 here. And then we're going to take this negative 15 and divide it by 2 over 2, which is just 1. Multiplied by x plus 1. This is going to turn into 25 over 30 x plus 2 equaling negative 2 over 30 x plus 1. So now what we got to do is get our x's together. So I could just subtract, well, let's add 2x over 30 here to both sides. When we do that, that makes this go to 27 over 30 x plus 2 is equal to 1. I'm going to drop this problem down here. So when we do this, we have to get this 2 over to that side because we want it just to be our term in front of our x by itself. So let's subtract 2 to both sides. And when we do that, we get 27 over 30x is equal to negative 1. Once we do this, we'll have just this equation. And what we're going to do is we're going to multiply both sides by 30. When we do that, these cancel out. That gives us 27x equaling negative 30. And then we're going to divide both sides by 27. And when we do that, those cancel out, and that gives us our final answer of x is equal to negative 30 over 27. Alright, let's take our next equation. Once again, I'm going to just drop these down. Oops. Okay. So, for here, we have x's all over the place. So what we're going to try to do is get all of our x's onto one spot. So the easiest way to do this is to subtract both sides by this quantity here. So we're going to subtract minus x minus 1 over x plus 3 on both sides. This is going to equal x plus 1 over x minus 4 minus x minus 1 over x plus 3 is equal to 0. That side goes to 0. Okay, so now what we're going to do is we're going to multiply by the common denominator. Our common denominator here is going to be x minus 4 times x plus 3. We got that from looking at this number here and that number there. So we're going to go x plus 1 over x minus 4 multiplied by x plus 3 over x plus 3. Remember that that is just 1. This number right here is 1. X minus 1 over x plus 3 is going to be x minus 4, x minus 4 is equal to 0. Man, I did not give myself enough room when I thought up of these spacings, did I? Okay, so we're going to multiply. We're going to multiply. Now notice they both are being divided by the same amount, so they can all share the same denominator. That'll be the quantity x minus 4 times x plus 3. And this will be x plus 1 times x plus 3 minus the quantity x minus 1, x minus 4. So what we're going to do is we're going to do a lot of foiling here. That's going to get multiplied by these two. That'll give us x squared plus 3x. This will be multiplied there and there, which will give us plus x plus 3. Okay, we got to really mind this negative sign right here. This guy is going to be really important. So we're going to say minus, because this is being minused and multiplied by these three amounts. So we have to make minus, and then we got to parenthesize this. Very important, because what we can't do is just give the minus sign to this x or there. We got to do these two parentheses, FOIL them, and then whatever we get is also multiplied by -1. So we're going to multiply this and this. This will give us x squared minus 4x. Here and here is going to be -x plus 4. And then we're going to leave it there. This one is going to be x squared plus 3x, -4x, and -12. Okay, so let's look at what similarities we got first. Let's simplify this a little bit. Okay, so this is an index of 1 and 2. This is an index of 1. This is an index of 1 as well. These two can go, and then this one and this one will go. So let's simplify that up. We get x squared plus 4x plus 3 minus the quantity x squared minus 5x plus 4. X squared plus, minus x minus 12. Now what we're going to do is distribute this negative. So what that means is the signs just switch on all of those guys. So we'll get x squared plus 4x plus 3 minus x squared. Then we'll have plus 5x. And then minus 4. So big thing here, well, let me get the bottom first. This will be x squared minus x minus 12. Big thing here is that this term and that term cancel. These ones are going to add, and then these ones will add as well. So we'll have 9x minus 1 over x squared minus x minus 12. That'll be your final answer there. Okay, I'm going to pause this real. Okay, so I cleaned this up a little bit. Let's look at this one real quick. This isn't an equation because there's not an equal sign there, hence equation equals. But this is a simplification rather. So we're going to look at this, and to figure out what this binomial factors into, we have to look at the 12. And the 12 is going to give us some numbers. We're going to see what multiplies to make 12. Well, we have 1, we 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. And then we got to see if what out of this group of numbers, which one will equal 7? Well, 1 plus 12 is 13. That doesn't equal 7. 2 times 6 is 8. That's not 7. But 3 plus 4 is 7. So what happens is we get x plus 3 and x plus 4 factors out, and you can check that. You can FOIL that back out and you'll always get this number, these numbers, x plus 3. Well, we know that x plus 3 and x plus 3 are the same thing, and we can write our equation like x plus 3 over x plus 3 times x plus 4. Well, x plus 3 over x plus 3, that's just 1. So this will be multiplied, and our answer here is x plus 4. Okay, let's look at this guy. So this one, we have to think of what numbers will can 1 multiplied by and equal 0. Well, one option is 1 times negative 1 equals 1, and that'll work. So what we're going to do is split this one up into x plus 1, x minus 1, divided by x plus 1 equaling negative 2. Now, we know that these will cancel, so we just get this one. X minus 1 is equal to negative 2. So what we're going to do here is add 1 to both sides. So x, well, plus 1 here, plus 1 there. We get x is equal to negative 1. Is that possible, though, is our question. So we're going to plug that back into our equation. Negative 1 squared minus 1 over negative 1 plus 1. Well, right here is a huge problem because we're dividing by 0, and we can never divide by 0. This gives us 0 divided by 0, which is a no solution. So this problem cannot be solved. This is a bad problem. Okay, what is an absolute value? Well, an absolute value is a number's distance from 0. And what that means is essentially anything in the brackets, we're going to take its distance from 0. So if I was to look at where negative 3 fell on a number line, it would fall on right here. And if I was to count its spots away from 0, that'd be 1, 2, 3. So negative 3, the absolute value of negative 3 is equal to 3. And 3 is 1, 2, 3. So absolute value of 3 is also 3. Now, let's look at this one. This one says x plus 7 has an absolute value of 3. So we need to figure out what x is. And if the absolute value of 3 is what it is, then we know that this quantity here, not the x, but the quantity that the x is landing here, and it's landing here. So we have a case 1. For case 1, we're going to say, well, if this quantity lands on 3, the absolute value is going to be 3. So we're going to have x plus 7 is equal to 3. Then we're going to look at this one and say, well, case 2. And case 2 is if it lands on the negative 3. Because if it lands on this negative 3, the absolute value is still 3. So we're going to say x plus 7 is equal to negative 3. So we're just going to subtract 7 from both sides in this problem, and we're going to get x is equal to 3 minus 7. And in this one, we're going to do the same thing, except it'll be negative 3 minus 7. This one's equal to x is equal to negative 4. Here, x is equal to negative 10. And we can look at that. If we started at negative 4 and added 7, we'd be 1, 2, 3, 4, 5, 6, 7. We'd be 3. That's our positive 3 value. That's where we land if x is negative 4 and that absolute value is 3. And the same thing for negative 10. I don't have time on my number line, so. Okay, let's clear this and look at this one. This is a little bit more complex, but the idea is still the same. So we have a absolute value equaling 1. So that means that at the end of the day, when this whole thing's done, we're looking at an x value that when evaluated will land us here or here. So let's solve that. We're going to say case 1 is where we land on the 1. So we're going to have 3 over 4x plus 9 is equal to 1. Case 2 is where we have 3/4 x plus 9 landing on the negative 1. So we're going to take 9 to the other side, so we'll get 3/4 x equaling negative 8. And then we'll have 3/4 x equaling negative 10. We just subtracted 9 from both sides. So now what we have to do is we're going to multiply both sides by 4. And I'm going to solve case 1 and 2 at the same time. So we're going to divide this one out. This is going to be 3x equals negative 32. And now let's just divide this out by 3. So we get a final answer of x is equal to negative 32/3. Over here we get 3x is equal to negative 40. So we're going to divide by 3 on both sides. That gives us our case 2 of x is equal to negative 40/3. So we have 2 answers when it's an absolute value. Let's look at our last case for our linear equalities. We're going to have something that's going to either land on 5 or negative 5, so we have to write those cases up. Case 1 is where square root of x plus 3 is equal to 5. And then the other ones were square root of x plus 3 is equal to negative 5. We're going to remember to get rid of a square root. We square both sides. That's going to give us x plus 3 is equal to 25. This one will give us, where we got to square both sides. So now we get, look at that. Both sides are the same. So we really only have to solve just one of these. So we'll get x is equal to 25 minus 3. X is equal to 22. And that's just a result that whenever you have a square root, the square root's always considered like this. There's always an absolute value underneath the square root sign. That's just a result of how the square root works. But I thought I'd show it to you anyway. So this one is a linear expression, x is equal to 22. And that's where I'm going to stop it for right here. That was all that we are going to talk about for linear equalities. Have a good day.